7.5 Linear inequalities in two variables. When we are working with these inequalities, we have an x and we have a y, which means we are graphing them. So the first thing we have to do is to solve for the y, then change the inequality sign to an equal sign, graph the line using slope and y-intercept, and then because of the inequality signs that are less than or equal to or greater than or equal to, draw a solid line through those points. If they are not equal to, you are drawing a dashed line or a dotted line, and then shade. If you have something that's y is greater than, you're going to shade above the line. If it's y is less than, you shade below the line. You can always test ordered pairs with these two. So if we look at our first example, we have 3x plus 5y is greater than or equal to 30. So we're going to start with 3x plus 5y is greater than or equal to 30. We're going to get the y by itself, so we're going to move the 3x over. We have 5y is greater than or equal to negative 3x plus 30. From here, we divide each side by 5, so y is greater than or equal to negative 3 over 5x plus 6. So our slope here is negative 3 over 5. Our y-intercept is 6. So we're going to plot our first point at that 6, then go down 3 to the right 5. Down 3 to the right 5. Remember, we can also go up 3 and to the left 5. Up 3 to the left 5. So we give us our line. We would draw our line through these points as best we can. And then because it is y is greater than or equal to, we would shade above the line. So anything above the line on the coordinate plane would be shaded. If we look at our next example, we have 3x minus 2y is greater than or equal to negative 4. So we're going to start again with this 3x minus 2y is greater than or equal to negative 4. Get the y by itself, move the 3x over by subtracting it. So negative 2y is greater than or equal to negative 3x minus 4. We are dividing by a negative 2 on each side from here, which means we are going to switch the sign. So y is less than or equal to 3 over 2x plus 2. So we have a y-intercept of 2. Then we have a slope of 3 over 2. So we're going to go up 3 to the right 2. Up 3 to the right 2. We can also go down 3 and to the left 2. Down 3 to the left 2. And then again, this is equal to, so we're going to draw a solid line through these pairs, or these ordered pairs. And then it's y is less than, so we're going to shade below the line. For our next example, we have y is less than or equal to 3 minus 2x. So I'm just going to rewrite this to be in slope-intercept form. So y is less than or equal to 3 minus 2x. We're going to swap the 2x and the 3 to be y is greater than or equal to negative 2x plus 3. So we have a y-intercept of 3 and a slope of negative 2. So 3, then go down 2 to the right 1. And then up 2 and to the left 1. And draw your line to the points. So we are going to have a line that goes like this. And then y is greater than, so we will shade above that line. So anything above that line gets shaded. For example 4, we have y is greater than or equal to 1 minus 3x. So this, again, we're just going to rearrange to where it's y is greater than or equal to negative 3x plus 1. So we're going to start at 1. We're going to go down 3 into the right 1, down 3 to the right 1, down 3 to the right 1. Oops. can also go up 3 to the left 1. And then draw the line through those points. We are going to shade above this line because y it's greater than or equal to, so again, above the line. Our next part of our lesson deals with the inequalities that are not equal to. So we have a greater than or a less than. These are going to be dotted lines. And then again, we just shade above or below depending on what the inequality sign is. So if we look at example 5, we have 21 minus 3y is less than 9x. So we're going to solve this for y. We are going to move the 21 over by subtracting it from each side. So we have negative 3y is less than 9x minus 21. We're dividing each side by a negative 3, so we're going to switch the sign. We have y is greater than negative 3x plus 7. So at 7, we would put our first point, then we're going to go down 3 to the right 1, down 3 to the right 1. We're also going to go up 3 to the left 1. So now with this, because it's not equal to, we're going to do a dotted or dashed line through these points. And then its y is greater than, so we would shade above the line. For example 6, we have negative 14 plus 2y is less than negative x. So we're going to move the 14 over first. Oops. Add it to both sides. We have 2y is less than negative x plus 14. Divide by 2. So y is less than negative 1/2 x plus 7. So we're going to go to 7 on that y-axis. Go down 1 and to the left 2. Down 1 to the left 2. And then up 1 into, down 1 to the right 2. Down and then up 1 to the left 2. Again, this is not equal to, so we would draw a dashed line through these points. And then we would shade below it. For example 7, we have 3 minus y is less than negative 5x. So we are going to subtract that 3 from each side. We have negative y is less than negative 5x minus 3. Then we divide by negative 1, switch the sign. So y is greater than 5x plus 3. So 3 on the y-axis, we're going to go up 5 into the right 1. Or down 5 and to the left 1. And then we're going to do dotted lines or dashed lines through these points because it is not equal to. Now its y is greater than, so we would shade above the line, and it would be just like this. For example 8, we have 10x plus 8y is less than 64. So we are going to resolve this for y. 10x plus 8y is less than 64. Move the 10x over, subtract it from each side. We have 8y is less than negative 10x plus 64. Divide by 8. So y is less than negative 5 over 4 x plus 8. Go to 8 on our y-axis, plot our first point, go down 5 to the right 4. Down 5 to the right 4. And then down another 5, 2, 3, 4, 5 to the right 4. So this is going to give us a line that looks like this. And then we shade below it because y is less than. Sometimes you're going to be given word problems and you are supposed to create the inequality from it. So if we look at example 9a, we're writing a linear inequality to represent the information that's given or the graph that's given. For example, A is that Elijah can spend at most $8.25 on snacks for a party. Carrots cost $2 per package, and grapes cost $75 per package. So we're dealing with carrots and we're dealing with grapes. So each bag of carrots is $2, so that's 2 times C. And each bag of grapes is 75 cents per pound, so that would be 75 cents for each pound of grapes. Now he can spend at most, so that amount has to be less than or equal to $8.25. For B, it says Ramona has $18 that she can spend on food for her dog. Dry dog food costs $5.50 per small bag, and wet food costs $2 per can. Write a linear inequality that describes how many bags and cans of dog food Ramona can buy. So we have dry dog food, so it's $5.50 per small bag, so that's $5.50 times D. And then cans are $2 per can, and then she can spend $18 on food, so that amount has to be less than or equal to $18. For the next example, we have a dotted line and it's graphed. Now with this, we're going to have a y. Normally, if we have a y is equal to, what's our y-intercept? It's 2, so it's going to be plus 2. What's our slope? It goes down 1 to the right 2, so that's negative 1/2 x. Normally, if it was just a straight line, no shading, this would be our slope-intercept form equation for it. However, because the shading is below the line, the y is less than negative 1/2 x plus 2. And then because it's a dotted line, we're not going to include the line underneath the inequality. So we just have y is less than negative 1/2 x plus 2. For D, we have a y-intercept of 4. So our B is 4. Our slope, we're going up 1, 2, 3 over 2. We can also go down 1, 2, 3, 4 over 3. So that's positive 4 over 3. So we're looking at this point and this point. So we're going up 4 to the right 3. So that slope is 4 over 3. And then our y-intercept is that 4. So y is, it's shaded above. So y is greater than or equal to, use your slope, 4 over 3x plus 4. Sometimes we're going to have a y or an x. You have to be careful with this because a y is greater than or equal to, or a y is greater than or less than a number. You either are having a horizontal line, that x alone is just a vertical line. So if we look at example A, we have y is greater than or equal to 4. So 4 on our y-axis is here. We are drawing a straight, solid line because it is equal to through that 4 on the y-axis. This is y is greater than, so we would shade above that line. For B, we have y is less than negative 2. So negative 2 on our y-axis is here. We're going to do a dotted or a dashed line through negative 2. and then it's y is less than, so we would shade below it. For x is less than or equal to 5, 5 on our x-axis is here, and then we're going to do a solid line through that point because it includes the 5 it's equal to. So then this is y is less than. If anything less than 5 is that 4, 3, 2, 1, so it would be anything to the left of this line for this graph. For D, we have x is less than or equal to -1. So again, solid line through -1. And then x is less than, so we're going to do to the left. For our next example, we are writing the linear equality for this. So this goes through the y-axis, so we're going to have y shaded above, so y is greater than. It's a dotted line, so no line underneath the inequality sign. And then where does it go through the y-axis? At -1. So y is greater than -1. For B, it's going through the x-axis, so x, it's shaded to the left, so that's going to be less than. It's a solid line, so we're going to put a line underneath that inequality. And then it goes through 2, so it's x is less than or equal to 2.